Welcome everybody. This is our weekly OPI Lifecycle Provisioning Technical Working Group. Welcome to our weekly meeting. Last time we didn't complete the overview of the boot synchronization proposed by Reza from HP. So I would like to spend at least the beginning of this meeting just finishing that. I posted the link to the pull request and specifically the file that you can view. It's still unmerged. We intend to merge it once it passes the CI. And Reza, if you want, you can share your screen and continue the walkthrough from the last time.
Sure, thank you, Boris. Let's see here. Sharing. Can you see that?
Yes, it's up.
Yeah. And thanks again, Boris. Thanks, everyone. So I think last time we finished the use cases, and basically we were talking about supporting single and dual DPUs, but no more than that. Then we mentioned that we're not going to talk about yet. We're not going to talk about the multi-host case where one or more DPUs are attached to multiple servers within an enclosure. So we're not going to talk about that. I did make some adjustments to the assumptions based on the comments last time. One of the comments was regarding the 3-volt aux in terms of the FRU being always available. So I made a statement that the out-of-band communication from the BMC should be limited to accessing the FRU or security chip on the XPU if they're available. So just to clarify that, because in some cases they may not be available.
Reza, just to remind, also from the previous conversation, there was an action item to add the kind of definitions terms table that will help us with all the acronyms. What is the platform BMC, if you remember, what is the AMC that you call it, or the DPU BMC. So I understand you didn't do it, but just a reminder, maybe you can update.
Sure, thanks for the reminder. I will add that terms. Take a note here. Yes, I will do that. I suppose to, yeah, I will do that. And just for those who were not here last week, I was using the term AMC to mean add-in management controller, BMC for baseboard management controller, traditional use case, and CMC for the chassis management controller, just so that we'll all be clear when we talk about management controller exactly which one we're talking about, because there is some confusion for overusing or overloading the term BMC when we mean when it's applied to both the card, the add-in card, or to the baseboard manager. So just wanted to have some clarity around that terminology. Right, so I'll continue here. But yes, but I will add that. Thank you for the reminder, Boris. The second assumption that the XPU may ignore transitions in the PE reset signal. And this is, bearing in mind that there is a PCIe interface and then there is a compute complex, such as an ARM complex. And in some cases, I think that some XPUs, they only apply the PE reset to the PCIe interface. I'm not aware of any case where it's applied to the compute complex on the XPU, but I am also aware that the card may just completely ignore the PE reset. And so the only way to reset the card in some cases may be to cycle power to the server. So that's something we wanted to bear in mind, that there is an assumption that PE reset could be ignored by the card. And that leads to number 3, which means that there will be perhaps there may be separate mechanisms to reset the interface or the compute complex. Number 4, that is the XPU may start to boot as soon as it detects stable application of 12 volt and 3.3 volt. This is one of the traditional uses of the PE reset signals, that when that's released, it's usually an indication from the host that the 12 volts and the 3.3 volt signals are stable. But my understanding is that some XPUs are not waiting for that. They detect the stability on their own, and then the card may start to boot on its own. There was something else there. Yeah, so those 3 are related regarding the PE reset signal. And then number 5 is an XPU is agnostic as to if the 12 volts and the 3.3 volts is coming from primary power or auxiliary power. So we know that in some future implementations, the XPU may be powered by 12 volts aux power and allowed to come up before power is applied to the processors, and so before BIOS or UEFI is allowed to run, the XPU would come up and perhaps be configured by some higher domain manager that's not in the server. But that auxiliary power is it's the same power that powers the BMC, that is the management controller on the motherboard. And so those, when powered by auxiliary power, those 2 could come up at the same time. The XPU and the BMC would be booting at the same time. But the XPU has no way of knowing that which power it's being powered with, whether it's auxiliary power or primary power. The XPU has no dependencies on the status of the OS server. That is, it does not necessarily need the server OS to boot before the XPU is booted. And I'm not aware of any such dependencies. So if there's anyone that has a use case or an assumption around that, please do let me know. But for now, at least, I think the XPU needs to boot up before the server OS boots up, and that's what number 7 is related to. And then I added a clarification based on some comments from last week, that in the event that the XPU fails to boot, that after some appropriate timeout, then the UEFI or BIOS will still pass after the rest of post or BIOS initialization, that the UEFI will pass execution over to the server OS to boot. So while the server OS may have some dependencies on the XPU being booted, it's not a guarantee that it will always boot. And so in those rare cases where the XPU fails to boot, we'll still allow the server OS to boot, and then we can manage that error at a higher level.
As just a thought here, we basically have 2 options of either not booting the main processor at all, or boot into the BIOS and wait in the BIOS. either BIOS or UEFI, right? And if I remember correctly, there is an information exchange that happens either in BIOS and UEFI between BIOS UEFI and the board management controller on the chassis management controller, right? So the question is like how we capture that. Like,
Okay.
do you follow what I'm trying to say?
Yeah, so you want to say we could potentially have two use cases, one which is the one that's stated here, we allow the OS to boot, and the other one is we go into some maintenance mode.
Yeah, because
Okay.
we still might need to communicate some information in the boot process, so the wait state is different, or maybe like you stated, the maintenance mode boot. Yeah. Does it make sense, or?
Yeah, it makes sense to me. Yes.
Mm.
Yes, I can add that clarification. I don't know if anyone else has got any more clarity they can put on it.
I just think that it's hard to keep adding all these different modes. Like it's you don't know if the BMC is in charge or the AMC is in charge. You don't know if the cores are on or off. Like it's gonna make things really complicated. You don't know if I don't know if that is really the right solution. It's already really complex. So, but anyways.
Do you have a suggestion then? Like, I understand this is a complex issue, but do you have any way we can simplify this?
I would have come at this from the other end, is to say, hey, not knowing anything about what's running on the BMC and who makes your server and who makes your DPU IPU card, like how would it work today? And then list through the changes that we would want to make so that we're not sort of minimizing the changes. You know, I can't imagine us saying that, like, to be OPI compliant, like the server vendor has to make XYZ changes to their BMC. Like the BMC is really hard to change. So I just it feels like it feels like we're making a bunch of assumptions here.
There are changes.
That's what this section is. I mean, we
Yeah.
want to make sure that when we, that we cover all of these use cases in the section, we come up with a solution.
So I have a hand up. Three things here. Number one, I think what Rose is doing to enumerate all of the cases and all of the scenarios that have to at least be considered is really valuable. And we need a catalog of all the possibilities, no matter how complex. And if it's really complex, it's good reason why we need a multi-company standards open source body to try to deal with it, right? Because if every company tries to do it with the DPU vendors pairwise, it'll be even worse nightmare than it is. So I think this is a great effort. Number two is we absolutely have the scope to say, to be OPI compliant, to be a server hosting OPI compliant DPUs, you got to conform to the following spec. And this is why we have server vendors in the mix, and DPU vendors in the consortium to agree to that, right? The whole point of standards is to agree to those hard things. Now, to Dan's point, we may end up having a prioritized list or a subset that we support initially with others to follow. It's perfectly okay for us to have a roadmap of items. So does that all make sense to everyone?
Yeah, and just to add on top of what Joe is saying, and to answer Dan's question as well, I think already today, with consumption of DPUs in the different server platforms, we already see changes were made in both the BMC code, the BIOS and UEFI code on the server side, and obviously the implementation on the DPU side. And I think this is true for both Dell and HP. Reza, correct me if I'm wrong, but this is what happened already today. So I think it's very useful to see that picture what's happening today, and then go through the list that Reza is presenting on different assumptions that we're having to the GPUs, and see how we can solve that problem for everybody.
Yeah, and you can see how this is working out, because Rez is from HPE is presenting this, and we're all kind of agreeing, yeah, we need to go through this whole scope. And you don't hear Lee Ballard going, hey, hold on a second here. So, I mean, you know, the people who've been doing this work and care about this are invested in this approach. So that adds a little bit of weight to it, I think. Anyway, sorry, Ted, I think is next.
Yeah, so I think one way to potentially address this is we haven't yet decided what is the master. We're kind of coming at it from both the DPU and the host BMC at the same time. And I think we collectively need to decide that one of those is the master and determines the boot policies. From my perspective, it makes sense if the host BMC is the master, and it can decide whether or not it cares about whether the DPU is active or not. If we're in a completely decoupled environment where the XPU is booting across the net and is just simply providing bump in the wire type services to network traffic, it really is irrelevant to the host whether or not the XPU is live at any given point in time. So it makes sense to me as we start from a BMC perspective, which is what is the boot policy for the XPU? And then within that boot policy, we can have things like, okay, what is the timeout that the host wants to apply before it assumes the XPU is not going to come up and boots without it? What are the other attributes we put inside that space? I think, Reza is right in what he's lining up here, but I think Dan is correct that we need to look at this more broadly than just this one aspect.
Well, actually, number 10 addresses the point you made. When the XPU is equipped with an AMC, it shall be subservient to the server BMC. And based on the comments from last week, I added the statement that other cases will be considered later. So it's not the only case we want to consider, but Boris had given us some guidance in terms of, let's pick a solvable piece of this big puzzle and address it, and then we can always come back and modify as we add more and more pieces.
Yep, I would agree, except I think number 10 is the wrong way around, because we may have more than one XPU in a host, and then you run into, okay, which is the master in that scenario? There is only ever one host BMC, and it makes sense to have that as the master controller, and then the AMC or the other BMCs associated with the XPUs are subordinate.
And if they are multiple AMCs or multiple XPUs in the server, you're assuming that a domain manager, higher level domain manager, will determine which one is the master. Is that?
Well, actually, I'm assuming that the BMC would determine which is the master. So you wouldn't need to have a separate service to do that. Now, you could obviously set up your BMC, host BMC, to take that, to essentially hand over responsibility to a domain controller. But in the environment where I don't think OPI can demand or can expect such a thing to exist. So it makes sense for the host BMC to be responsible for all the programmable infrastructure services included within the host itself.
I think that's what number 10 says.
Yeah, and that's where I would disagree. That's when someone puts an AMC into their card, it's not to be subservient to the server BMC. So that's not its point. The reason why it's there. Making changes to the server BMC is pretty expensive, and so the reason why those AMCs even exist is that there is an entirely different model where you strive to minimize the changes in the server BMC while still introducing these programmable infrastructure devices.
I think there is no argument about that, Dan. I think we all agree. I think that what Reza was trying to say on this page is that this use case is the first use case that we currently trying to solve, and other use cases we're going to solve them later on.
But this goes back to the modes. You can't have a mode where one mode assumes the other BMC is subservient to it, and then the other mode assumes that the other BMC is a subservient to it or to some other entity like that.
Well,
That doesn't
well,
work.
this actually covers two cases. This covers the case where there is an AMC and where there is no AMC. If we would like to prioritize and discuss and address the case you're mentioning, which is the condition where there is a BMC and there is an AMC, and the AMC is sort of the supervisor, we could have that discussion and prioritize accordingly. But what this one, number 10, addresses is perhaps some existing cases, meaning the case where there is no AMC and the case where there is an AMC. So we cover two cases with this statement.
I think we all saying the same thing. I think Dan is just don't like the language. So then you can propose any different language. But I think that per previous discussion, I still stand firm on this. We should address those use cases that Reza is putting here, that even if you have AMC or AMC is absent, still the board management controller, the platform BMC is still in charge. This is the first use case that we're trying to solve. The second use case, when a DPU or IPU is in charge, this will be solved after we solve the first use case, if that makes sense.
I think the two that I'm interested in are not covered by the 10th assumption. I think the most important one to solve first is the case where you put some of these programmable infrastructure devices into a server that doesn't have any BMC changes for handling these types of devices. The device should still work and do something interesting enough for you to be able to move it into the right mode so that you can operate in such a server. So that I think is the most important. That's sort of like the null case, is like, hey, there's nothing I can do about a legacy server or a server that doesn't yet, it hasn't become self-aware about its programmable devices. I think that's the most important case is how do we bootstrap this thing off the ground? And then, the other case that I think is much more applicable to these programmable infrastructure devices is not that the AMC and BMC have some sort of hierarchy, but that they both exist and that the management infrastructure, which is a lot easier to change than the code on the BMC, is aware of all the AMCs and the BMC on the board and then synchronizes it at that level. Those are the two cases that I think are going to be much more common than this particular case. This case, it feels like we're going and we're going to require a bunch of changes to the BMC, which is going to be really hard to assert that that's going to be there for when across all the different vendors that you're using for your deployment scenario.
Yeah, I understand where you're coming from now. I think you're looking at beyond the horizon when things should be seamless. I'm looking a little closer in at this first example, where what exists today actually does require special handling because of the software-defined nature of the XPU. That is, things such as PCIe managers are in software, they're not in hardware. And there's a little extra hand-holding that's required both from a BIOS and a BMC point of view for the existing XPUs. I think one of the goals of this organization and this set of discussions is how do we get away from those special handling cases, where I think that's where we're all wanting to go, is no special modifications to the BMC, no special modifications to BIOS for any special handling for these cards. But for the near term, I think until we can get silicon changes, we'll have to address these issues. And the kinds of cards that exist today do require some special code from the BMC and BIOS.
That's the
makes
assumption
sense.
I'm challenging. That's exactly the one that I'm challenging is, do they really? Are we sure about that? Because usually BMCs don't program like things that are programmed in software, right? That's not usually their cup of tea. You have something running on top that is going to talk to the software layer. But sorry, go ahead. You have your hand up.
So just a thought. I think one of the things I struggle with is there's a lot of text here and there's a lot of text here in the boot sequencing markup, right? I feel like it might be better if we had like a behavior specification or an actual, use case, and then we did like a sequence diagram and see if we even need these assumptions, right? Like, I'm not sure what's the reason some of these are here, if that makes sense.
Yes, absolutely. Very fair statement. And this is the reason I suggested a survey, and Boris had put it in the chat. A survey of the XPU for the XPU vendors to describe some of the behaviors, very specifically around things like the PE reset. Does a card ignore PE reset? How should we handle it? Is the card can the card respond to PCI config cycles within 3 seconds after reset is released? These are problems that exist today. It's a PCIe violation. So when BIOS is up and starting to pull the card, say, "Are you there?" And the card's not there because its software hasn't run yet to give it its personality. So these are some of the things that we're working around today that require special handling from both BIOS and the BMC. And so if like to encourage the XPU vendors to please do answer some of those questions, that will help to trim down some of these assumptions and narrow the focus.
Julia, you have a comment as well?
It feels like we're treating the assumptions as requirements. And I think every assumption enumerated here, except 10, because I'm very much in Dan's camp of not believing that's a hard requirement. But I think we're treating everything as a requirement when these are assumptions in the wild today. And these are behaviors we can probably find amongst every vendor.
Yeah, number 10 is sort of stated as a requirement for a specific case, and not meant to exclude the other cases.
Yeah, we might rephrase it rather so people feel more comfortable that the first use case that we're trying to solve is when AMC is subservient to the server beams.
Okay, you could
Something like
soften that.
I'm not dismissing that, Julia and Dan. Obviously, we all see that customers and the ecosystem is marching towards the independent model, for sure, infrastructure endpoints. But we feel that it's not mature yet, it's not there yet. Customers are not ready for that yet. Definitely, we are going to solve that problem. I'm just feeling that we have much more pressing issue right now with both Dell and HP and other server vendors and all the DPU vendors that we have currently acquire and shipping the cards that we want to solve first. Dan and Julia, you have your hands.
So question though, what is the AMC's role in boot sequencing and coordination?
So hold that thoughtfully. Let's give Dan and Julia time to comment, and I'll show you the survey where this is exactly the question that we're asking vendors to provide. Go ahead, Dan.
Yeah, I just I agree with the pressing need. Like if you go back to our OPI website, even there's only one picture in the website, and it's showing the transition from you know, a server with peripherals with a smart NIC or whatever to this separated infrastructure device. And so what you're saying is that we're actually going to go and do the provisioning for the left-hand side picture first, and then do
This
the
is what we
right-hand
have
side
then.
picture?
We don't have anything else right now, right? All the DPU vendors currently are shipped in the servers, except for Intel, right? Shipped in the servers where BMC is in charge and BMC controlling the boot sequencing. So we have to solve it first.
Yeah, so I wonder if there's a better alternative to that. So if we're saying like we're going to go solve the left-hand side peripheral problem first, then
So Dan, to make progress, what I believe we should do is write up the alternate and we'll incorporate it into the overall boot document, right? So the boot documents could end up ultimately with a bunch of sections enumerating the various cases, and the prioritization of the cases. I can't give you a 100% answer right now. I don't think Boris can either, except that we know this one is important because we hit it, every month. And HP is proposing it, so they're hitting it too, right? Without going into any antitrust stuff. We know we're hitting this, so we know we have to solve this one. What you're bringing up, I agree with, but maybe write that one up in parallel, and we can then ultimately maybe we have to do both at the same time, to your point, because we know this.
Julia, have your hand, and then again.
So I was going to basically suggest the same thing Joseph said, was that we can't block on any one thing. We kind of have to operate in parallel.
Can we? I'm not sure I agree with you, Julia, because from the history of this subgroup, we were unable to launch any productive parallel discussion so far. People are not really working offline, so we have to tackle one small thing at a time.
I agree that right now, to gain the initial velocity, we probably have to compromise. I think the challenge before us is to find a level at which we can focus and then accelerate. And I think the problem is that we have a very deep area of knowledge that is required to actually have these discussions and articulate it. And then we have the various factors of what's in the field today and what people are doing, and versus where we want to take things. And all this has to be married together, and it's not going to be pretty no matter what we do. So we're going to have to find compromises.
I agree. This is why we're starting with this first thing. HP and Dell coming with already existing knowledge, how we do things today. And we want to get there very quickly without any distractions. We want to go through these assumption use cases. We want to draw a picture of sequence diagram. We want to show you the challenges that we both feel and see with DPU vendors. Maybe Intel is an excellent DPU vendor and is going to do things completely different. And we have this mode of separation, whether a DPU, IPU is in charge or the server is in charge and everything is resolved. The PCI Express state machine is completely in hardware. It's always on and we see no issues. We don't need any changes in BIOS, UEFI, and BMC. I don't believe it, but let's assume that for a second. We need to solve it also for other vendors, which are completely misbehaving today. So if we can focus ourselves, and we, Dell and HP, going to present to you in these meetings what is happening today in the field and what problems we're facing and trying to solve them, then we can build on top of that and see how we can mitigate and see ourselves in the future with much better approaches, and what changes we need to ask DPU vendors to make in their silicons in order to get to the future that Dan is asking for. Make sense? Go ahead.
Makes sense. Oh, yeah, makes sense. Thank you.
Can I pull us back to that picture real fast? Can I share it just really quickly?
I can stop sharing.
Just to clarify what we're saying. Oh, I can't. It's not like
Yeah.
Teams where I can't see.
How do I stop sharing?
Then let me pause you for a second, right? I think we understand what you're saying. I think that's pretty clear. I think we already decided that we're going with the first use case of platform server is going to manage BMC. We're going to solve this problem first. So I really want us to continue focus on that.
So in that use case, is it this picture on the left? This is the use case that we're going to go to first, is that there is no separation. There's that trust line has not been broken. And
We're not talking about trust. We're talking about only boot synchronization. Who is booting who? Means we all understand that when BMC in the server and the server wants to do a network boot or NVMe or Virtual emulated boot from the DPU needs to be booted. It doesn't really talk, we don't want to talk here about the trust yet, but very simple use case. Host wants to boot out of emulated NVMe or Virtual device or the network boot. In order to do that, DPU needs to come up. In the BIOS, today it's not happening. There is some synchronization that needed to allow DPU and IPU to boot first before the server can continue booting. This is the only case that we're trying to solve right now. We're not talking about the TRICE domain. We're not talking about traditional SmartNIC versus infrastructure endpoint. We're only talking about allowing server to wait until the resources that DPU provides are available to it, because no vendor today can boot up immediately and make all the emulation available, because even on Intel, you're running SPDK, for example, for emulation. So, and all the other vendors as well. So we need that application to be up and running so the host can boot out of emulated NVMe device. That use case is the most simple one I can find and explain why we need that synchronization. Does it make sense?
That use case makes sense, but your solution that you're jumping to is you're saying that the BMC must be the master of that process. And that's not the only solution to that use case.
I think we've stated that, you know, very clearly. It's not the only one, but that's the one we're going to address first, because that's what's here.
And then
today.
we'll solve your use case when BMC is not in charge. And
No,
we can solve it differently.
they're the same use case with two different solutions. So that's what I'm saying, is that let's not have the solution lead what we're standardizing here. If the use case is, I want to have this split between the platform on the right, and I want to, and we should enumerate exactly what you just said. That should be the first part.
Let me rephrase this.
Okay.
Let me change that assumption for number 10, and ignore the case where there is no AMC. Right? We have an XPU that does not have a management controller, and we want to solve that case. And to Boris's point, we're just trying to get this thing to boot up. That's the struggle.
And for your point, then we identify two approaches here. First is in-band solution, which we are going to deep dive after Reza finished his assumption. The first approach is in-band. How can we leverage PCI Express without board management controller? You just need to let us move on, right? We want to explore the first solution. Can we solve it using PCI Express state machine? For example, spinning into CSR with all the timeouts and everything without ever touching the board management controller. The second approach that Lee showed previously last week is, with assistance of the BMC, can we solve that problem? Once we identify both of those solutions in a little bit depth, we can then choose the best one. We are not saying that we must use BMC for the solution. We're saying there are several approaches. If you have the third approach that solves that use case, we are very much welcoming that. We want to deep dive into all 2-3 solutions that we have. And then once we have them detailed, we can then choose the best approach, or we say we have to support all of them. I don't believe so, but let's say this is the case. Do you agree, Dan?
Yeah, I mean, we've been saying, oh, these are the only two, and then we're going to work on stuff later. I think there is a third solution where these two pieces come up independently. It's an implementation detail if you have an AMC or not. So I think that we should put that on the list. If our first provisioning solution is just how do I get the VirtIO block boot disk to pop up on the host side before I boot the host, then we can go through that case. And I don't think you need to assume that there's an AMC on the IPU DPU.
So if you have a solution for that use case without any BMC, we are very much welcoming to you to provide that information for us, and we can review it. Absolutely.
Okay,
But
yeah.
yes, the use case identified, I think that, again, if people disagree, speak up. But the first use case, that the most simple one that we can identify is we're trying to boot the host from emulated NVMe or VirtIO. So we need to wait somewhere in the UEFI or legacy BIOS for this device to pop up, so we can continue booting the host OS from that device. Make sense?
Perfect. Yeah, I can bring that in next week and talk how we do that, and that's independent of how of whether you have an AMC or not.
And if you're doing that using the PCI Express state machine, that solution we're already exploring. So it's not a third solution. Okay. With CSRs and everything we discussed with Andre and everybody else from Intel. That's not a third solution. That's a second solution. First is with board management controller assist, and second, in-band only using PCI Express machine. And we stated several problems with both of those approaches. So that's not a third solution. If you have a third one, please bring it in.
Yeah, there's a third solution. Yeah, for sure.
Perfect.
Yep.
Excellent. Okay, so let's give a chance for Reza to finish today, and then
Yes, I think that's it for me. Thanks, everyone. Great comments, and I'll make some adjustments.
perfect. I want to share just a few couple of things before we finish up. First of all, the survey that Reza was talking about, I committed it into our boot sequencing markdown page. This is a survey. And I cannot emphasize enough how it's important for the DPU and IPU vendors to actually fill that questionnaire and help us understand what is happening today. Because that will change completely the assumptions that Reza is presented to us. Right, Reza?
Yes.
And then if Intel, for example, doing things completely different, filling that survey from Intel perspective is going to help tremendously, saying that we don't need any adjustments for Intel cards. They can sit in any server, and we don't need to create a separate solution for that. So I see here representatives from Marvell for sure. So Chetan, can you take an action item replying with answers on those questions from Marvell side?
Yeah.
Okay, so this is an action item for you. Intel, Dan, can you identify who will be a point of contact to answering those questions from Mount Evans side?
Yeah, when I bring that third option next week, I'll answer these questions in that presentation.
Okay, but if you can just at least the answers, provide them offline, we can submit them separately from the discussion as well. Or at least some of them. Somebody from NVIDIA here? I'm not seeing anybody from NVIDIA. Joe, can we bring this topic to NVIDIA not participating in this work group to the TSC?
Yep.
Thanks. Something is going on here. We have lost participation from NVIDIA for some
Yep.
reason.
We'll bring it up.
Thanks.
And I just want to emphasize that these questions are related to very low level behavior, very low level.
Yeah, basically the PCI Express state machine and the booting of the DPU and IPU cards themselves with all the voltage applicability and the booting, right?
Yes.
Yeah. AMD, I don't see Vipin here. Okay, I'll reach to Vipin separately to ask those questions as well. The second comment that I have in addition to the survey is now with Reza addition, we have 2 pages, which for me at least starting to be a little bit confusing. We have a page on boot sequencing and we have a page of boot up coordination. So the boot sequencing, at least when I started, is supposed to be a high-level overview of all different state machines. So we have initial boot up, we have reboot scenarios, graceful shutdown, error handling, all of that. And then I wanted to create a separate pages for all these different use cases. So for initial boot up coordination, I created a coordination markdown page. Now we have assumptions and use cases and entity explanation on both pages, which is very confusing to me. So anyway, if anybody has any kind of mitigation plan, how can we make this more clear? Maybe.
Yeah. So I was thinking about this too, and that's kind of what I was talking about earlier, is that maybe at the top level of the page, you describe what we want on the page, whether this is kind of if this is supposed to be the use cases and requirements independent of implementation, right? And then the implementation details of how you would implement that is more in the, this is kind of the high level marketing requirements, and then the implementations on the coordination page, or just merge both the pages, one of the two.
What I was thinking is the boot sequencing page is a high level page with all the use cases and assumptions and different scenarios on a very high level, and coordination page goes into solutions. This is why today the coordination page without the Reza additions looks like this. We have the in-band approach that I want to deep dive on how we can solve it in band using PCI Express. We have out of band with platform management BMC that Lee put up. So this page, at least in my view, is supposed to be solution oriented versus a boot sequencing page supposed to be use case and assumption. So
Yes,
maybe
then-
Reza,
maybe we can move the use cases and assumptions that I added. Maybe I can move those over to the
to the
boot up.
previous page. Yes.
Yeah.
I think that will make sense. And then we can state on this page, Lee, I like your suggestion. Maybe on the beginning of each page, we can actually describe in several words what this page is supposed to be.
Yeah, the executive summary of the page.
Yeah. So I'll take an action item of providing the executive summary of this page. And Reza, if you can then move and merge the use case and assumption from this page to the boot sequencing page, if that's fine.
Yeah.
We still need a table with acronyms and terms. So that's also an action item from the last time. And then we're really looking forward to have then third option, in-band PCIe, out-band via platform BMC. How would you, in high level, in several words, how would you describe the third option?
The third option is that the IPU DPU is independent of the host, but is in control of the host. So it provides the boot image or PCI PXE boot networking path for the server to come up. It takes there's a couple steps in that process, but there's no coordination there's no in-band PCIe, there's no coordination between the host and the IPU, and there's no coordination between the IPU and the BMC, because all of that is treated as on the other side of the trust boundary.
I don't understand how then you can hold UEFI BIOS in waiting state until the IPU booted up. Can you just maybe spend a couple of or maybe 1 minute to explaining what?
Yeah, is the IPU in an independent power domain? Is that the way that's accomplished?
Doesn't have to be.
Oh, so you boot to nothing and then reset afterwards?
I want to get my my full details straight before I go through it. That's why I want to do it next week. But that's effectively the idea, is that you don't necessarily know anything about what's running on the host, or you don't know anything about what's running on the host, and you don't know anything about what's running on the BMC. So you have to go back to the lowest common denominator, which is Pixie boot and disk boot, and that's what we do.
Yeah, I think the challenge we are trying to address is even before that's possible.
Yes. The PCI Express machine is not identified by the root complex. This is what we're saying. You try to boot your IPU, and the PCI Express firmware that is responsible for implementing the endpoint is not up and responding properly to the PCI Express messages. This is what happened then.
Yeah, we have a solution for that. So I just want to get the it's a multi-stage process. The PCIe has to come up within the 100 milliseconds or so. So inside the device, that comes up well before the processors on the device come up. So this requirement, you have to do it that way. So let me get all my details right, and then
I'm pretty sure. Yeah,
that's
go ahead
the
and
high level,
get
is that-
fetch your details for sure. But from my conversation with Andre and Maciej here from Intel on the call, it falls into the first category of in-band PCIe. Whether it just works or doesn't work, that's another issue. But yeah, go ahead and fetch your details. But I think until you do, currently we have only two working assumptions, that either we can solve it using in-band PCIe, and we have a lot of problems with timeouts, errors, retries, and state machine, or we have to involve the platform BMC. If we can find those two solutions, and maybe there is a third one, we can deep dive on those, and then eventually we can vote which is the best solution going forward. But yeah, I think that's clear. Okay, so it was a very good discussion today. Unfortunately, we're not making a lot of progress, but I think it's very important to have everybody on the same page at least. What I want, Reza, if you don't mind, for the next week, since Lee already provided the out of band, I think we want to deep dive a little bit more on the in-band, right? With CSR and all of that, we have a couple of ideas in the issue here for host boot synchronization from Slack, CRS support, and timeouts and all of that. So what I would like us to do is to propose that change in here in this page, and have the in-band PCIe via CSR or any other mechanism to be a little bit more detailed here. So anybody can take a shot at this. Reza, if you're up to it, that's fine. If somebody from Intel, Maciej or Andre want to do it, that's also fine. What do you say, Reza?
I have some ideas, but I'm not ready to present it yet. We have some legal loopholes to go through first.
Mhm.
So.
Okay. I think also Marvell, Chetan, Marvell also stated that they proposed the CSR solution, CRS, yeah, CRS solution with PCI Express. Maybe you can help out with this page as well.
Sure, I can take it internally and see.
Okay.
Yeah.
Perfect. Okay, so let's meet next week. Thank you for your discussion today.
Thanks, everyone.